Hi, everyone. I'm Thomas Howard. I'm one of the technical marketing engineers for the Identity Services Engine, or ISE, and I wanted to talk with you about ISE deployment architectures for nodes, services, and scale today. This is a sort of a beginner series letting you know about how ISE deployments work and the different ISE nodes. And so this is part of our basics series that we're starting for the calendar year 2022. And so we're going to be doing a lot more of these kind of beginner level sessions for you. So if you find this helpful, keep tuning into the additional sessions in the coming months, like Rigo said, because they are more geared towards the beginner user for ISE and might even help you learn a few new things about some of the ISE basics that you didn't know before. So these are the things we're going to cover today in terms of the different ISE nodes. We're going to get some terminology out of the way, help you understand how the ISE distributed system functions, let you know about the different services available that you can enable and disable within ISE. And then we'll get into how you actually scale a deployment from a single standalone ISE node that you might use for an evaluation or a demo all the way up to a large distributed deployment around the world. And we'll talk about the different platforms available to you, from appliances to virtual machines and even our recent cloud options. And we'll get into some different performance and scaling tips and even how to automate your deployment with some of the really cool APIs and automation tools that we now have available in ISE 3.1. So with that, let's get into it. So as a quick recap, just uh, 2 days ago, I did another webinar on ISE with zero trust, or for zero trust in the workplace. And I wanted to start with this just to kind of set the framework for all the discussions and the topics we're going to be going into today, because this really reinforces the way that ISE helps you solve for zero trust in the workplace. So ISE is a AAA server, authentication, authorization, and accounting server that you deploy in your network. And it allows you to do enterprise-based network access control using your many network devices for wired, wireless, and VPN, so that when your users and devices come in, we can authenticate them uh, using backend identity stores such as Active Directory or LDAP or ODBC or SAML, OAuth, things like that. And that allows us to ensure that it's one of our trusted users and devices that are accessing the network. Or maybe if it's not, maybe it's just a guest. Either way, we're able to differentiate the level of access that we want to provide them to our network. And then once we do authorize them to the network with those privileges, we have the ability to share that information with our security partners and other Cisco applications and services so that they can do their job to protect the network with their specific security technologies. And if they detect any kind of bad behavior on the network with those technologies, or maybe they discover that we let in a device that has some known vulnerabilities, then we are able to uh, get input from them that will help us to quarantine that user, that device, so that any vulnerabilities they have, they won't be able to be infected by some other device on the network, or they won't be able to propagate the malware or whatever they were doing that was malicious. So this is a great thing that we call rapid threat containment, because the idea is we want to minimize the exposure time of a piece of malware or something to minimize the blast radius of the infection. Uh, so this is something that we think is very useful and is all critical to providing zero trust in the workplace. So to help you do that, we deploy ISE in a variety of different ways, whichever suit your needs. So the first is a physical appliance. So for that, we have the Secure Network Server, or SNS appliances. And we have a variety of uh, platform sizes, from we used to have the older series, the 3500 series with the 3515 and the 3595. I put those in sort of a light red because those are now end of life, and you shouldn't buy those. You may still have them in your network, and that's okay. You can still use them, They're still supported, but just know that you don't want to try and buy those as new. You really want the 3600 series. And I would even note that the SNS 3515, if you want to, if you have that appliance and you are thinking of upgrading to ISE 3.1, which is our latest release, know that the SNS 3515 is not supported anymore. It does not have enough resources for the ISE 3.1 release. So just be aware of that, that you would potentially want to upgrade that before moving to ISE 3.1. So we also support virtual machines, and we have all these different hypervisors that we support virtual machines on. We don't care what the underlying hardware is that you run these hypervisors on, as long as the amount of resources that you allocate to the virtual machine matches the same physical resources in the SNS appliances. And the idea here is that we want to allow you the flexibility of using virtual machines, but we just want to make sure that the virtual machine resourcing matches the performance of the SNS appliances, the small, medium, and large, the 3615, 3655, and 3695, because that helps us, to make sure that you have the same amount of resources, the amount of scale and performance is predictable, and that's really important. And we'll get into some more performance issues with virtual machines a little bit later. Finally, I want to talk about one of the newest offerings that we have, which is the ability to deploy ISE in the cloud inside of Amazon Web Services and their Elastic Compute Cloud, the EC2 instances. We are working on support for other cloud providers like Azure, Oracle, and Google. So look forward to announcements about that later this year. But for now, only AWS cloud instances are supported with ISE. The last thing I will mention here is when you do an ISE deployment, you can mix and match all of these different appliances or virtual machines or cloud instances in a single ISE deployment. We don't care how you instantiate ISE, as long as it's clear what size it is, small, medium, or large appliance equivalent. And as long as they're connected together securely, so they can talk together with less than 300 milliseconds of latency, that's all that matters. And you can mix and match these different types of instances any way you like. The other thing I'll mention is whenever you install ISE on an appliance, a virtual machine, or in the cloud, you will get free 90 days of licenses in your instance to play with. You can do it for a lab, for a demo, for testing purposes. Whatever you want to do, you can use. You just install ISE, and you will get 90 days of 100 endpoint licenses, and you get one device admin appliance license, and that basically gives you everything that ISE can do. And so if you want to play with it, see what you think of ISE 3.1, or if you want to try it in AWS and see how that works, you got a full 90 days to try it out. So just be aware of that, and I encourage you to use it. This is how I do all my demos. is I just install. I don't worry about the license. I can just create another one when I need to. So with that, let's get into the actual ISE personas. And the first one, so ISE has these different functions, and we break them out into what we call personas. The first one is called the policy administration node, or PAN. This is basically what you log into. This is the web GUI. You authenticate, you log in, and this is where you do all of your policy configurations, your settings, and anything that happens there, the ISE system would replicate to any other nodes, so that they could be in sync with everything that has been configured. And the policy administration node also maintains a centralized database for guest and BYOD registrations, as well as it's the place that you would connect to do any kind of REST API configuration for automation and things like that. Then the next persona is the monitoring and troubleshooting node, or the M&T node. Uh, that is basically where all of your AAA logs, your authentication and authorization, accounting logs, all of those get sent to the M&T node, and it can then replicate those logs out to other syslog remote targets. It can generate summaries and reports for you that are available in the ISE dashboard in the policy administration node. And it also even has some limited queries that you can do to get information directly from those logs in the M&T node for the AAA logs. Now, the next one, the policy service node, or PSN, this is really the primary workhorse of ISE. When you think about ISE doing authentications and authorizations, this is what you think of. This is where all of the TACACS requests are handled, the radius requests come in, and they're mapped against the authentication and authorization rules. Any kind of endpoint profiling probes, all the data with DHCP and HTTP and Nmap, all that stuff. It's all handled on this node. And then when the authentication requests come in, ISE can talk to the different identity stores like Active Directory or ODBC. It will do that directly. It doesn't need to involve the policy administration node for that. And then if you want to do guest or BYOD registrations, the policy service node is the one that hosts the web portals that they connect to do that, and also any kind of MDM queries that need to happen for checking compliance or posture, that happens through the policy service node. It also has a couple other things for doing threat-centric NAC and the SGT exchange protocol. Those are fairly advanced features. We'll touch on those a little bit later, but just know that those are some of the capabilities that are in the PSN. And finally, we have the Platform Exchange Grid node, or PXG. This is the Platform Exchange Grid is basically a way of propagating information to our security partners in a publish and subscribe model. So we can asynchronously send information to them about the endpoints and users coming into the network so that they are aware immediately when there is a new endpoint authorized to the network. We can send them context about that user or that endpoint to let them know, hey, Thomas just came on the network. He's at this IP address. If you want to go kick off a scan, you can do it. Or if you are a group-based firewall, you have the ability to know that it's Thomas at this IP address when you see these packets coming in and he's a member of a specific group. And now you can apply that group membership that Thomas is a part of in your access control list policies on that firewall. There's other things you can do, like kicking off vulnerability assessments and other things, but that's basically how we use the Platform Exchange Grid to asynchronously notify our security partners about incoming endpoints and users in the network. It also has the ability to handle the rapid threat containment and threat-centric NAC requests I told you about to help quarantine any rogue users or devices, and it uses REST APIs to do that. So those are all the different ISE personas. What's interesting is we have the ability to run all of these personas on a single ISE node, or we can fully distribute them. And so let me kind of go through a practical example of how they all work together, and then we'll get more into the standalone options or the fully distributed options. So the way this works is, you're an ISE administrator and you have a policy administration node that you can log into and do your configuration. And then it will replicate any of those configuration changes that you make to the policy service node so that it has the latest settings and authentication policies that you want to use on all of your network devices when they receive requests coming in from different endpoints and users in the network. So that way it can authenticate and authorize them according to the policy you configured. And then it's going to go ahead and log that information to the monitoring and troubleshooting node. That can then, of course, be updated quickly in the UI that you're looking at. Or you also have the ability, if you're using the platform exchange grid, we can send that context through the platform exchange grid for things like, like I said, the session directory for new users coming on, or maybe we have scalable group tag mappings for users and um, groups. We send that out to the platform exchange grid node, and it will replicate it out to our different security partners who can then use that contextual information to do their security services. And then if they detect that there's a problem with that new user, that device, they know to call into ISE and say, hey, I need you to quarantine that device. And that will hopefully quarantine it and prevent it from causing any more problems. So that's sort of the whole flow of everything that we just talked about in the AAA process that ISE does. And again, this is really designed to help you with that zero trust model to assign only the right permissions and privileges to those endpoints and devices coming into your network so that they're only able to get access to the resources that they need and you don't have a problem of excessive trust. But if they do get through and maybe they are able to, or if they are malicious, they try to do something, we have those other security services watching them. And if they do anything that looks like some bad behavior, we're able to quickly quarantine them and prevent that from happening any further. So back to that standalone ISE node we were talking about. When you install an instance of ISE, by default, it is in a standalone mode, meaning it can do all the ISE services on that single node by itself, and it is not part of any ISE deployment. If you log into it, you go to the deployment page, you will actually get a note about it being a standalone mode. And you will also notice if you were to try and register another node, basically to try and create an ISE deployment with a second node, you can't do that right now because it's still considered a standalone node, and you must convert it to a primary administration node. And once it's been identified as a primary administration node, then you can begin to add other nodes to the deployment. So the way this works is, again, you got that standalone node, you just installed it, you can now play with it, do your demos and testing, and if that's all you need to do, you're fantastic, right? But usually you actually want to deploy it in production. And for that, we highly recommend that you have two ISE nodes for high availability purposes, right? And then the way that you would do this is, like I said, you need to take that one of the standalone nodes and make it a primary, and then you're able to go ahead and register that second device as part of the deployment. And one will be the primary, and the other will be the secondary. And the way you can do this is when you can, once you elect the primary administration node, you're able to register that other node by simply specifying the fully qualified domain name that you gave it when you installed it, and provide the credentials, and the primary will be able to contact the secondary and join it into your first ISE deployment. Now, another option is for a lot of customers, most customers actually they have small deployments. They only have, two nodes. But if you want to get a little bit bigger, some customers, they typically might have, they don't just have, two data centers. Maybe they have three data centers. They have three regions around the world, right? Like the Americas, Europe, and Asia. And so sometimes it's nice to have three nodes that they can spread into each of those different areas. So three node is another option. And the other thing that this does for you is it will allow that third node on the bottom to be what's called a health check node. And it's the one that can actually test and verify that the primary policy administration node is up and running and connected and everything is working just fine. If it goes down, maybe there's a WAN outage, or if something happens with a bug or a crash or whatever, it would detect that it's no longer responding. It would automatically notify the secondary node that it should now be the primary. So that's what that third node is as a health check node. Um, you can do this in larger deployments. You just have to specify a separate node to be that health check node. So you can do 3 nodes like this, but a lot of people will go ahead and do a medium-sized deployment where they have a pair of policy service nodes that they can put in different data centers. And you'll notice that between these two diagrams, what we're doing is we're taking the platform exchange grid persona and we're moving it down to the policy service node. It doesn't really matter where you put that service. It's an option. So it's up to you on how you want to do it. But just want to let you know that's perfectly acceptable. But as you start to scale out, if you want to do, like I said, highly available nodes, you can put them in different regions. That's really nice, right? For redundancy, maybe you have 2 data centers, and so you want to put the primary in one and the secondary in another, along with the PSN. The other thing that happens is customers want to have, again, higher availability, so they will have multiple PSNs in each of those data centers. And so that may be something that you want to do depending upon the scale or the reliability that you need. You could even put each of the PSNs in its own data center, depending upon how many you have around the world, or in a different country. You can spread them out however you need to, as long as you have 300 milliseconds or less of latency between the PSN nodes and the PAN and M&T nodes. You're fine. That's all that matters. So like I said, some customers, they want to do 3 different regions, so that's also an option. So I'm just trying to give you different examples of the flexibility we have here with this distributed deployment and the way that we can meet your needs for your high availability and your different regions that you may have around the world. So once we determine maybe you're growing your network, or you're expanding your ISE deployment, you're trying to cover more territory now, you're successful with some initial deployments and you want to do more with it, we can go from a medium-sized deployment up to a large deployment. And in the process, what we're going to do is we're going to kind of split out the primary and the secondary nodes. And what we're going to do now is we're going to split the services off of those so that the primary PAN becomes dedicated with a primary M&T. Okay, so we're going to split out that M&T node on the primary, right? So now we have dedicated PAN node and dedicated primary M&T node, and then we have a dedicated secondary PAN and a dedicated secondary M&T node. All right. So now you officially have a large deployment when you have dedicated PAN and M&T nodes like this. All right. And so this is kind of the minimum size. You could actually have only 6 nodes if you wanted. You would have the primary PAN, the secondary PAN, the primary M&T, the secondary M&T, and 2 PSNs. That's a perfectly acceptable large deployment as well. Whenever you have distributed PAN and M&T nodes or dedicated nodes like this, that is considered a large deployment. And then what you can do is that gives you the bandwidth, the capacity in the PAN and the M&T nodes to really scale this up and go from 2 PSNs, 6 PSNs, all the way up to 50 PSNs and 4 platform exchange grid nodes. All right. So with that, you're able to go up to 2 million active concurrent endpoints on your network with ISE. Okay, so this is the full capacity of a single ISE deployment today is 2 million active endpoints with a large ISE deployment like this. Now, you can handle 2 million active endpoints without deploying 50 ISE nodes. But this is just if some people they want to have redundancy and high availability in multiple regions, and for that reason we give you the addition of extra appliances and virtual machines. But if you were to max out the capacity on every one of those policy service nodes, you'd be way over 2 million. But the bottleneck at that point becomes the policy administration node and the M&T node's ability to handle that many logs and requests and different things happening in the network. All right, so that's sort of how you distribute things. And then I just wanted to revisit this idea of centralized and distributed deployments. So most customers, we recommend that they centralize things inside of data centers. So here we have, data center 1 and data center 2. They might all be, they could actually all be in a single data center, depending upon, how large your company is and how it's spread out around the world. But oftentimes with larger customers, they want to spread the primary and secondary nodes across different geographic regions or even different continents. And if those are the main hubs for your company, you would also typically put several of your policy service nodes there, potentially with load balancers to handle the requests, and you kind of centralize everything in those couple of data centers. Now, there's no reason you couldn't have 3 or 4 or 5 or more data centers. You just would only be able to have the PAN and M&T nodes in 2 of those. The PSNs you can spread anywhere in the world, and hopefully you can see here that we can even have standalone PSNs in different countries, or you could do a pair of PSNs in each of those countries if you wanted to. It all depends on your needs for high availability and the capacity of your users authenticating to the network in those regions. So the only other thing I want to mention here is that earlier I talked about that need for 300 milliseconds or less of latency between the PAN and other ISE nodes. So just keep that in mind. One of the things is, customers, we recommend, again, start with a centralized deployment and then only distribute it if you need it. But be aware that if you do distribute it, those WAN links going across the oceans, those may be slow depending upon what kind of WAN links you buy. And if it's greater than 300 milliseconds, that's not going to work. Eventually, that node would become out of sync. It wouldn't be able to keep up with the replications and changes, and it wouldn't work very well. So you need to have that 300 millisecond or less latency between the nodes. And speaking of WAN link outages and things, what happens if the primary PAN is unreachable? Either it goes down because you're doing an upgrade and you need to reboot it for 20 minutes or more. Maybe there's a WAN link outage and the PSN cannot contact the PAN. Whatever the reason, if that happens, the PAN does more than just configuration. Like I said, it has some centralized databases. It's like basically the central clearinghouse whenever you create new users, like guest users, or you do BYOD registrations. If you have a new endpoint that you're profiling for the first time, things like that. Those kinds of activities are effectively bottlenecked by the primary policy administration node. And so if it goes down for a period of time, those operations will not be available. So I just want you to be aware of that and plan ahead when you're going to do your upgrades. And in the process, what you can do there is you can actually, if you're going to do an upgrade, what you can do is you can actually temporarily make the secondary node the primary node. Okay. And that way you don't lose a primary node while you do your upgrades. So just keep that in mind whenever you do your upgrades. All right, so let's get into the services. So we've talked about the different personas. And here what you're going to see is we have the ability to enable and disable different personas. So what I talked about earlier is how you would distribute the different ISE personas on different physical or virtual nodes, right? And this is basically where you do it. You turn on and off those personas with these switches. So you can see the policy administration persona, you can see the M&T persona, the PSN persona, and then down at the bottom, you also see the platform exchange grid persona. Under policy service node, you see that we have a bunch of different services. Like I said, the policy service node is the one that handles all these different transactions for TAC-ACT, AAA, device administration, all these different things. So you see all those additional checkboxes. And this is how you would enable and disable these additional services on the PSN. Okay. So as you create these different roles, you could just log into these boxes and you would enable or disable these switches to make them the PAN node, the M&T node, the PSN node, or the PX grid node. And then for each of the PSNs, you would enable or disable the individual services. When it comes to profiling, there's an additional set of things that you can configure. So at the top there, we were just looking under the general settings for a single ISE node. If it's a PSN, you have the option to configure profiling. And when you configure profiling, what that means is you actually are configuring profiling probes. And the probes handle different protocols so that we can grab different attributes about different endpoints, and we're able to gather that information and understand more about them and understand what kind of device they are, so we can make a decision with profiling policies about how much access we should give them on the network. So what you can see here is the first one at the top left is NetFlow, and you can see I put like a warning exclamation point next to it. And the reason for that is, first of all, you notice it's disabled by default. So if you have a new instance, you go into it, you will see NetFlow is disabled by default. And the reason for that is if you try to send a bunch of NetFlow information to ISE, it is not meant to be your general purpose NetFlow collector. That is not ISE's job. ISE is meant to be a AAA server, right? But there are some situations where you you may need NetFlow data to help understand what type of device is connected to your network, and the only way to get that is by looking at net flows with source and destinations or particular protocols. So you can do it, but just be aware that you don't want to send unfiltered net flow straight to ISE and expect it to parse everything and figure it out and still handle all the other things that it has to do in your network. Be very, very careful with that one. But DHCP, that's the next probe. That is very common. We use that all the time. And basically what you do there is you just add a secondary DHCP forwarder in your network device config, and it will send it straight to ISE, and we're able to parse the request and the response and get more information about the endpoint that was assigned an address. We also have the ability to do it with the DHCP span, but again, be careful with your spanning. Don't send a full span of all traffic, because that just creates more work for ISE. And that's not what you buy ISE for, to be a packet filter. You really want to handle authentication authorization requests. So only send DHCP information in the span tab. The next one is HTTP. This is really critical if you want to differentiate some of the modern workstations and mobile devices like iPhones and iPads. So you can get some basic information from DHCP. You'll get the MAC address. You'll know, oh, this is an Apple device. But if you want to know that it's actually an iPhone versus an iPad, the only way to get that is by looking at the HTTP user agent to see which kind of device it is. The most useful one, I believe, is the device sensor. So the device sensor is a capability that we have in our iOS switches and our wireless controllers. And actually, I shouldn't say our iOS switches, because Meraki also does device sensor capabilities now. So it's really, the higher end Cisco switches do it. The Meraki MS390 does it. The Catalyst 9Ks do it. Even some of the Catalyst 3000s do it as well. So you can do device sensor, and what this does is it gathers up uh, CDP, LLDP, HTTP, DHCP. It takes all that stuff we were gathering earlier and it packages it up really, really nice for ICE. So you don't have to do all the forwarding separately. It'll just go ahead and send it to us in a radius accounting request, and it will go ahead and give it to ICE. Now we can use it and do profiling even easier than before. The next one in the upper right is an Nmap scan. So notice that it is off by default as well, and that's because actively scanning some endpoints can trigger some problems for them. So we let you do it on your own. We're not going to just start scanning your entire network with Nmap by default. That's up to you. So just be aware when you do that. Do it with caution. Then DNS will basically give us FQDN information for the endpoints. If you want to do an SNMP query, you can do that. Be aware that, again, actively querying endpoints can cause problems for some of them. So use that one at your own discretion. And then the ability to get some additional information out of Active Directory for certain Windows devices. We have that probe as well. And finally, you'll see the PXGrid probe. That is something that we can use with some of our PXGrid partners to take information about specialized endpoints. And so for that one, we use something like the Cisco Industrial Network Director or Cisco CyberVision, or we also have several partners that can do profiling of specialized devices in medical, manufacturing, utilities, things like that. They use very specialized protocols, and your normal networking protocols aren't going to be enough to identify them. So we can use those specialized protocols in those products, and they will send us asset information via PXGrid. We call this context in. So normally, I told you about how ICE is sending the context out to the security devices. In this case, we have um, Cisco CyberVision, we have Industrial Network Director, and another one, Cisco Endpoint Analytics. We can get information out of them and use that so that when we see a specific MAC address, we go, oh, look at all this other asset info, and using that, we can make a profiling decision. So those are all the different profiling probes available under the ISE PSN persona. And, I've been talking about all these different protocols. Sometimes people want to know when they're setting up their ISE deployment, what are all the different protocols that we use between the different ISE nodes, and how does it work, and what ports, and who's talking to what, and it can get pretty crazy. So if you ever need to open up certain firewall ports for node communication, or your security engineers want to know why ISE is sending things on certain ports, well, this is your diagram. We put this in all of the ISE installation guides, so if you ever want to refer to it, you know where you can always find it. All right, let's talk about the different platforms now. I did talk earlier about how we have the physical SNS appliance, we talked about the virtual machines, and we talked about cloud providers. So what I put here is basically a reference of our different appliances, our SNS appliances, and what we're using for the actual hardware in terms of processors, cores, RAM, disks, all that stuff. Because if you want to build a virtual machine, you want to spec it out so that it's basically the equivalent of one of the SNS appliances or better. So as long as you do that, then you should receive exactly the same performance, whether it's a physical SNS appliance, a virtual machine, or a cloud instance. So we do, one thing I didn't talk about earlier was the ability to install ISE in AWS or Azure on top of VMware Cloud. So basically VMware Cloud acts as a hypervisor in those cloud provider environments. And so if you want to do that, you could do it, and you would use these same appliance specs here to build out your VM in VMware Cloud. And you'll notice that we have the ISE and AWS is kind of grayed out there because we have a second slide over here. And these are the instance types for ISE and AWS. So when you go into AWS and you want to spin up some instances, these are the EC2 instant types that are available. You can see a couple of them are grayed out, the M58 extra large and M516 extra large. We're still working on those. We're not quite done validating those, but just be aware that we are trying to get additional larger instances qualified in the AWS environment. And there actually is another one that's not listed there yet, which is available today in AWS, which is the T3 extra large instance. That's the one that you can use for evaluations, demos, tests, things like that. Basically non-production type environments. You just want to play with it. If you want to use that, I've been playing with it when I do, practicing ISE deployments or testing things out, doing scripts and automation. I use AWS as my playground sometimes. And so use the T3 extra large and save yourself some money in AWS. So when it comes to provisioning these different appliances and virtual machines, automation is beginning to be a bigger and bigger part of what we do. And so we have the ability to use native APIs with VMware and AWS. If you've been watching our webinars in the past year, we've done several different webinars on APIs, automation, AWS, all that stuff. It's been fantastic to see how ISE has been able to progress and be cloud deployed. And so if that's something you're interested in, I encourage you to go back and look at some of those previous webinars. They're on the ISE webinars page or in our YouTube channel. So go ahead and look at that and see how that was done. So we also have APIs that you can use for ESXi, and then we also have the ability to provision things with zero touch using ISOs and configuration utility with the Cisco UCS, the SIMC BIOS, as well as VMware ESXi. Next month, Charlie Morton, one of our CX engineers, is going to be talking about how you actually do ISE installation on premises with the SNS appliances and VMware or hypervisors. And so tune into that one if you want to learn more about zero touch provisioning. He'll be going more in depth on those. So I often get asked, okay, Thomas, so I've got all these different options to deploy. Which one do you recommend? And so to me, it's really simple. I love the flexibility and the ease of deployment of a virtual machine. If you've got the capacity, you've got VMware or one of the other hypervisors at your disposal, it's really easy to quickly provision a virtual machine, spin it up, and you're off and running playing with ISE. And the flexibility of being able to change the underlying hardware is fantastic. And that includes the ability to use the SSD disks. I forget what it stands for, but the ability to use those disks, they are like 10 times faster than spinning disks, right? And so one performance tip is if you use SSD, solid state drives, that's what it stands for. If you use solid state drives for your M&T node, you will get like 10 times or more of the performance than you would of a spinning disk. So if you use one of our appliances, they all come with just spinning disks. And so you're not going to get the latest and greatest hard disk storage technology with spinning disks, right? So you have that option in a virtual machine. The other thing is all the appliances come with 600 gigabytes of storage. So if you have a really large deployment and you want to save a lot of logs, you only get 600 gigabytes on your M&T nodes with an appliance. Whereas with a virtual machine, you can scale it up to 2.4 terabytes. So again, that kind of flexibility is really nice on a virtual machine. The major downside to a virtual machine is we have seen time and time again where people will allocate a virtual machine but fail to reserve the resources, meaning, they want to share the resources of the CPU and the RAM. They want to share that with other virtual machines because that's how you increase your efficiency and optimize, right? Well, when ICE needs resources to authenticate users, it needs the resources. And if you wait on that, you may fail to authenticate your users. And now the network looks like it's down. And now you're in trouble because ICE isn't working. It's not doing what it's supposed to. And all because somebody else, somewhere else in the company, ran a database instance, they ran a big query, it sucked all the resources, and ICE wasn't able to do its job, right? So for that reason, you must enable resource reservation on virtual machines. And so that gets back to our appliance model. The only reason I recommend using an appliance is when you cannot trust your server or compute team or whoever manages your virtual machines and allocates those things for you. If you're not the guy doing it, uh, if you can't trust that they're going to perform the resource reservations, then you need to get dedicated appliance hardware because there have been so many cap cases, TAC cases on people that didn't do the resource reservations. It looked like ICE went down all because somebody else ran some application or process and it took the resources away from ICE. So be aware of that. The other reason is that sometimes in our political environments in our companies, um, some people define network devices as physical hardware, and anything that runs as a virtual machine, they consider to be a server or a compute resource. And so if you virtualize ICE, suddenly it's now a server or compute thing. And so that changes the ownership and the budgeting and all this other garbage for some companies. And so if you find your company works that way, you've got sort of your enterprise networking, your security, your compute teams. Um, you may need to pull the physical appliance card so that you maintain control of the physical appliance and it's not owned by a separate team or you don't get the budget for it or whatever all the other, political problems are that come with that. So be aware of that. The other question, obviously, now that we're moving into the cloud is, okay, Thomas, so when should I do something on premise versus the cloud? And what I'll tell you is, again, the flexibility of virtual machines take it to another level with the cloud. The ability to quickly provision it without having to worry about, gosh, do I have enough Cisco UCS boxes or do I have enough hardware that I can put ESXi on to run ICE and all this kind of stuff? Do you have to budget, plan ahead, order the gear, rack it, stack it, install ESXi, all that kind of stuff, for your on-premise stuff? Whereas with the cloud, you just go with a few clicks, submit your credit card, and AWS is going to spin you up some instances really fast, and you're ready to go. So I love that flexibility. I've been doing that a lot more lately, and it's fantastic for doing, especially with automation and trying to repeat tests and spin up deployments. It's really really nice. The downside, of course, to the cloud is um, if you haven't done it yet, there's a big learning curve. There's a lot to do. If you want to take advantage of that automation, there's a lot of different tools you might potentially have to go learn, like Ansible and Terraform. And if you're not a script kiddie and you're not a software engineer used to Python and other languages, that may be a lot of work for you. The other thing is, I think we've all heard in the news about a lot of big breaches that happened because people didn't lock down their cloud environments. They didn't put proper passwords on, and they didn't put in the appropriate security groups to lock access and different protocols. They didn't use strong passwords. I mean, all these different things, right? So you really got to be more careful. You don't have the benefit of having a firewalled perimeter necessarily. It's up to you on how you do it in the cloud environments. So you got to be careful with that. And then finally, I got a surprise AWS bill a few months ago. I thought I had terminated all my resources, but it turns out that I didn't realize that the disk storage volumes did not get deallocated or terminated, and so they just sat there in use and for several weeks. And at the end of the month, I got a big bill, and I was like, "Oh, how'd that happen?" Well, you learn, right? So just be aware that those kinds of things can happen in the cloud. Whereas if it's on premise, you buy it once and you kind of forget about it and you amortize it over a few years. So those are some of the pros and cons to think about, whatever works for you. So now let's get into the deployment sizing. I just want to talk about some of the things that we already have posted in our ISE Performance and Scale document, and it can hopefully help you with how you want to deploy ISE. So typically we think about things in terms of a small, medium, and large deployment. We've also talked about doing an eval or demos on a single standalone ISE node. So the thing to think about here is notice that both the small deployment and the medium deployment have the same total capacity, right? Whether you're on 2 nodes or 8 nodes there, depending upon what size of appliance you're using, right? You're limited to a maximum of 20,000 concurrent endpoints or 50,000 concurrent endpoints. And the reason for that is because with the PAN and the M&T nodes and the PSN nodes kind of sharing everything, the PAN and the M&T nodes become the bottlenecks, and so that's why you're limited to only 20,000 or 50,000 endpoints in those configurations. When you dedicate the PAN and M&T nodes in the large deployments, that's when you can really scale things up with ISE and do everything in a dedicated way. So just keep that in mind, depending upon what you're trying to do. Most of our customers are well under 50,000 endpoints, so you should be able to keep it to, the small and medium-sized deployments. But if you need the larger capacity, we can certainly handle that as well for you. So I keep talking about this idea of concurrent active endpoints. The reason why I do that is because that is how ISE is licensed. And the reason why it's licensed that way is because ISE is a Radius server. And the way that Radius works is it does AAA, authentication, authorization, and accounting. And the way it does accounting is basically whenever a session starts with a user or device being authenticated and authorized, that triggers a Radius accounting start event. That's the start of a session. And then if you disconnect by unplugging your Ethernet cable or disassociating from your wireless connection, or maybe the session timeout we assigned for your session, maybe you ran over that, so the network device is gonna drop your session, or maybe we just don't hear from you for a while, and so the network device drops your connection. Whatever the reason, those are considered stop events, and that is the end of a session. And so when we talk about maximum concurrent active endpoints, basically that's the number of active sessions you can have at any given time from these Radius start and stop events. And so at the bottom there, I put the deployment maximums because, again, depending upon what appliances you have for your PAN and M&T nodes, that determines the overall maximum deployment size that you can have. And then the other thing to talk about with respect to performance is, besides the overall deployment size, it's the capacity of individual PSNs and your ability for your deployment to handle spikes in traffic or peak demand. So the idea here is when you do your initial assessment to scope out the size of your deployment, the easiest way to do it is just, answer how many endpoints do you have in your network? How many phones? How many laptops? How many, cameras and IoT devices and, all that stuff? How many do you have? And some of those are going to be things that basically just sit there. They're on all the time, right? Your phones and your printers, they just sit there, and sometimes they're in use, but they're just always on, ready for service. Other things like mobile devices, they come and go, they roam, they power down, they hibernate, they do all these things, and so some of those things are more steady state, like your printers and your phones. Other things come and go with your users, and not only that, but even if a person is just sitting in a conference room, the phone may hibernate, drop a wireless connection, then come back alive to check some email or messages or something, and then just kind of keep going up and down. And if you don't have something like fast session resume, a fast reconnect, things like that. That can cause spikes in your authentication traffic. So you got to be aware of those kinds of settings on your wireless devices. The other thing is misconfigured devices. If they don't trust a certificate, they may sit there and retry and retry and retry to authenticate, and it's just always going to keep failing because they're not configured correctly with the right certificate or something, or the wrong password. That can be a huge impact on your authentication load on your ICE servers, depending upon the number of devices and what kind of device is doing it. I've seen 1,000 times the number of authentication requests from some of these devices compared to a similar device that's properly configured. So just keep that in mind when you are deploying ICE. You want to watch for those kinds of things and try to fix them as quickly as possible so you don't get too many of them and they really overrun the load on your icebox. The other thing that we get questions about is, do I need multiple ICE deployments? And there are several reasons why you might want multiple ICE deployments. They don't all have to be greater than 2 million endpoints. We have a lot of reasons. You can have much smaller ICE deployments um, with less than 2 million endpoints. And here's the reasons why. Obviously, some cases you do have more than 2 million endpoints. And so you need to have multiple ICE deployments to handle that capacity of active endpoints. The other reason is earlier we talked about latency, right? So if you have WAN links, you're just not willing to pay for faster WAN links to get that latency under 300 milliseconds, or um, you're in a place that you just can't buy a fast enough WAN link. You just can't put a PSN out in one of those locations. So you may need to have multiple deployments in different places. The most extreme example of this, I kind of put there, cruise lines, ships, naval ships. They're out there in the middle of the ocean. They don't have Ethernet cables to connect them to the mainland, or fiber optic cables. Satellite links aren't fast enough, and so they basically run their own ICE deployments on board the ships. And then when they get back to port, they can, resynchronize and whatever with other ICE deployments and policies and things. But that's basically how they run. The other reason is, organizational choice. Sometimes different teams, uh, you know, maybe they don't trust each other. Maybe they have different goals, different purposes, different security concerns. So they will organizationally decide to have multiple ICE deployments to meet those different goals. Uh, Finally, I've seen certain customers want to split up their ICE deployments for different services. So here you see the T stands for TACAX, the G means guest, and the R means radius. So some customers want to divide their ICE deployments by the type of service. So they have one deployment just to handle TACAX traffic. They have another one for handling the general corporate radius traffic, but then they have a totally separate ICE deployment just for guest because maybe they have a lot of guest services. And you can imagine hospitals and retail would probably fall into that separate guest category, right? You want to keep the guest traffic totally separate for security purposes and also for reliability. Um, uh, you wouldn't want it to necessarily affect your corporate traffic. And also, I've seen situations where the TACAX stuff has a lot of automation, and the amount of traffic that the tooling, the scripting can run on the TACAX nodes is crazy, and that would potentially affect your radius servers. So for that reason, we may want to separate things out. So the last other little factors here I want to throw out is just a lot of different things, sort of beyond just the ICE deployment. Just how can you optimize your ICE policies and configurations? We talked about with network devices, wireless stateless session resume, fast reconnect, things like that. Um, you can do things like MNT log filtering to minimize the number of repeat um, authentication requests. Like I said, if you get a misconfigured endpoint, you can just sit there and try and try and try again and fill up your disk with useless logs. So you can filter those things out. Optimizing your policy set so that the most frequent thing is at the top, just like you would do in a firewall. Um, be aware of your mobile endpoints and their high authentication rates, misconfigured devices, and we just talked about tooling with something like TACAC. So be aware of those kinds of things to also optimize your deployment. All right, so last thing is deployment automation. Uh, we have been doing a lot in ISE 3.0, 3.1 to improve our APIs. So we have these different APIs available that have enabled us as we move into the cloud to do all kinds of fantastic automation with things like Ansible and Terraform to really move into an infrastructure as code world. So this has been a fantastic thing. We have multiple webinars on these topics. If you go and look at our ISE webinar recordings, our videos on YouTube. You can watch these and learn more about them. But what's really cool is in ISE 3.1, we added a bunch of new APIs specifically to help you with deployment and the life cycle of your ISE nodes for doing things like not only provisioning the ISE nodes, like I said, but also doing patches, certificates, uh, joining the different ISE nodes together as PANs, PSNs, primaries, secondaries, all that kind of stuff, adding policies, adding licenses, and doing backups and restores. And if you're interested in this, the last webinar of 2021, our TME host Saquon did just a phenomenal job of what I call the fastest ISE deployment in history, where he was able to bring up like 6 or 7, 8 ISE nodes in AWS in 30 minutes. That included bringing up the instances, configuring them with digital certificates, joining them, and being able to run an authentication request through it. So all that stuff he could do in 30 minutes. So the tooling is amazing when it really comes to getting you set up and streamlined in an ISE deployment. So again, these are some of the sessions that we did previously. And again, Charlie is going to be doing on-premises ISE installation next month. So look out for that if that's something that interests you to get the next level deep dive into managing your ISE deployment. And with that, these are the resources for things I've talked about today, things you may want to follow up on, looking at our online resources, our videos, our community, things like that.